Welcome back. I hope you enjoyed that tour of campus. I certainly enjoyed being there. Wish you all could have been there with me, um, but I'm looking forward to when we can all shortly return to campus. So I just want to show you what your data table should look like approximately now that you've watched the video. The volume of vinegar for all three trials is 2.00 milliliters. It's a volumetric pipette. That's why you need 2 sig figs. For trial 1, I told you the initial burette volume, it was 0.25 milliliters. The final burette volume for that trial was 17.02 milliliters. So to get the volume of sodium hydroxide added, we just do final minus initial, which gives us 16.77 milliliters for a volume of sodium hydroxide added. Now for trial 2, remember our final volume was the same as the initial volume for the next run. So that was also 17.02 milliliters. Then I told you that the volume for trial, well, I didn't tell you anything actually, but what you should have had for a final volume was something around 34.1 milliliters. Remember, here you're going to need, in all of these, you need 2 decimal places. So you should have something around 34.1 mils for trial 2 final volume, but it's going to be 0.1 something or like 0.0 something. So it could be 34.0 something or 34.1 something. You have to read it correctly. But if you have something like 33 or 35, go back and look at the video again. For trial 3 initial volume, you should be around 3.4 milliliters, so it could be 3.3 something, 3.4 something, but you need the 2 decimal places. And again, final volume for trial 3 should be around 21.8, so 21.7 something or 21.8 something. So if you have something really different from that, go back and look at the video. And so then here, calculate these 2 values, and it's going to be V final minus V initial. So now let's go ahead and start to take a look at our calculations. So what we want to do, step one, it says here, what we're asking you to do here is to figure out what the exact concentration of sodium hydroxide is that we used for this experiment. I had told you in the video that it's around 0.1 molar, but we need to get it exactly now. So step one, what it's saying is in order to make this solution, we put 4 grams of NaOH into a 1.00 liter flask. And we diluted it until a total volume of 1 liter. And it's asking you to get a molarity. So remember, molarity is moles per liter. So we're almost there. We're in grams per liter. We just need to convert to moles per liter. So you need to convert grams to moles. So you convert sodium hydroxide grams to moles and then divide by 1.00 liters in order to get a concentration. I've told you the answer is going to be somewhere around 0.1 molar. As far as sig figs go, remember, 3 sig figs here, 4 sig figs there. With multiplication and division, you want to round to the lowest number of sig figs in your out of your variables. So this answer has to have 3 sig figs when you calculate it, when you finish with your calculations. And also you are going to need, right, for this conversion, you need a molar mass of sodium hydroxide. At minimum, you need to have 3 sig figs in your molar mass. I recommend having 4 sig figs because you don't want to limit the sig figs in your answer by the sig figs in the molar mass. And if when you have too few sig figs, you end up with round off error. So it's preferable to use a molar mass with 4 sig figs here. And so when you're done, you should have a concentration that's around 0.1 molar for sodium hydroxide. But again, make sure you have 3 sig figs. So you should now be done with step 1. Let's go on to step 2. Step 2 wants you to convert percent acidity to a concentration of acetic acid and vinegar because, in chemistry, we don't deal with percent acidity a lot. We deal with concentration. So let's look at the bottle. And the bottle here says that acetic acid is 5% acidity. What that means is that we have 5 grams of acetic acid in 100 grams of vinegar, or you could say it's, 0.05 grams in 1 gram. So what we did in step 2 is we told you, it means there's 5.00 grams and 100.0 grams of vinegar. So we're going to convert that to a molarity using a density of vinegar of 1.000 grams per ml. So let's set this up. So 5.00 grams of acetic acid in 100.0 grams vinegar. That's our initial ratio. And what we want to do is we want to get into concentration. And remember, concentration measured in molarity equals moles over liters. So right now we're in grams per gram. We have to get to moles per liter. So the first thing you're going to need to do is convert to moles. So convert acetic acid to moles. Again, you're going to need a molar mass to do that. And same thing, you have 3 sig figs right now in the top of this equation, 4 sig figs in the bottom. You want a molar mass with at least 3 sigs, and I really recommend 4 so that you don't create round off error by rounding your molar mass too much. So then after you do that conversion, you'll have moles acetic acid, and I'm just gonna move this over. Let's say we have however many moles of acetic acid you get. I'm just gonna say X, so you need to calculate this. Divided by 100.0 grams vinegar. So now we're in moles per gram. We need to get to moles per liter. So we gave you a density. We said it's 1.000 grams vinegar per milliliter. And then you need to convert milliliters to liters. So there's 1,000 mLs in a liter. And you can see that milliliters are canceling out, grams of vinegar are canceling out. So now I'll have moles of acetic acid per liter. Those will be my final units. So that is a concentration. So if you did it right, you're going to have something around 0.8 molar. And if you remember the experiment 7, titration of vinegar lab, if you remember the number you calculated, this is going to look pretty similar to you. Because we were doing a very similar calculation for that lab. And as far as sig figs go, just remember 3 sig figs here, because if you look at our equation, 3 sig figs, 4 sig figs, 4 sig figs, 4 sig figs, the smallest number of sig figs is 3, so your answer should have 3 sig figs. Okay, so now you should have finished step 2. You're ready for step 3. So what step 3 is asking you to do is calculate the moles of sodium hydroxide that you used to neutralize all the acetic acid. So remember, what we did in the titration was we added sodium hydroxide. That's what was in the burette. That was our titrant. We added that to our Erlenmeyer flask containing our vinegar until it turned pink, or until the sodium hydroxide neutralized all of the acetic acid. So now, because we know the exact volume of sodium hydroxide we added, and we know its exact concentration because you calculated that in step 1, we can calculate exactly how many moles of sodium hydroxide we added to our flask in order to neutralize the acetic acid. And the calculation of that is quite simple. You just need to use the molarity of sodium hydroxide and the volume of sodium hydroxide. So the volume of sodium hydroxide is from your data table. For trial 1, it will be 16.77 milliliters. That's the volume of sodium hydroxide that you added for that trial, or technically I added. So remember, molarity is moles per liter. And if we multiply molarity times volume, which is in liters, liters would cancel, and that would give us moles. That's what we want. So this is just molarity of NaOH times volume of NaOH. That's the equation. That's what I'm doing here. So moles per liter of sodium hydroxide, we have our concentration. It's about 0.1 mole per liter. You need to use your exact number with 3 sig figs. And we're going to multiply that by volume. Right now, our volume is 16.77 milliliters. We can't multiply liters times molarity because our units wouldn't cancel. So we need to put milliliters into liters. So remember to do that. You divide, whoops, I don't want that thing. Let's get rid of that. To go from milliliters to liters, you just divide by 1,000, which means you're just moving the decimal place over 3 places. So that would just look like this, 0.01677 liters. So if you go ahead and multiply 0.1 by 0.01, or 0.1 with 3 sig figs by 0.01677 liters and get your answer, that will give you the moles NaOH. So for this trial, this answer is going to be somewhere around 1.677 times 10 to the minus 3 moles. This answer should have 3 sig figs, however, because our concentration is going to have 3 sig figs. This volume has 4 sig figs, but since our concentration only has 3, we have to round to 3 sig figs. So this would be 1.68 in my case times 10 to the minus 3 moles. I'm not exactly sure what you're going to get with your exact concentration, but I can just tell you it should be somewhere around this value. So let's go ahead now and look at the next step in the calculation. So we finished step 3. So this is step 4, where it says to use the balanced chemical equation to determine how many moles of acetic acid were originally present in the flask. So the reason we do the titration, again, is because if we know how many moles of sodium hydroxide we needed to add to neutralize the acetic acid, and we know how sodium hydroxide and acetic acid react together, then we can use that to figure out exactly how many moles of acetic acid were there to begin with. So let's look at the balanced chemical equation here. And we see that 1 mole of acetic acid reacts with exactly 1 mole of sodium hydroxide in order to neutralize it and turn it into water and this salt. So that means if we started off with only half a mole of acetic acid, we need a half a mole of sodium hydroxide to neutralize it. If we started off with 1.76 moles of acetic acid, we need 1.76 moles of sodium hydroxide to neutralize it. So in my case here, I have 1.68 times 10 to the minus 3 moles NaOH. That's what I added in my calculations. Yours might be slightly different. Times the molar ratio for the balanced chemical equation. 1 mole of sodium hydroxide for 1 mole, I'm going to call this acetic acid, AA. 1 mole AA, moles of NaOH cancel out, and I can do this calculation in my head. I can multiply by 1 pretty well. And this is step 4 that we're working on. So since I needed 1.68 times 10 to the minus 3 moles of sodium hydroxide to neutralize the acetic acid, it means I had 1.68 times 10 to the minus 3 moles of acetic acid initially in the Erlenmeyer flask. So let's go up to take a look at step 5. So we finished 4, we're on to step 5. Use the moles of acetic acid to calculate the molarity of acetic acid in vinegar. Okay. And it says, this little hint here, you will need a volume to calculate molarity. So volume of vinegar we'll need, that's from our data table right here. Here's the volume of vinegar that we use, 2.00 milliliters for every trial. Okay, so step 5. So again, we want a concentration. We want to get a concentration which is measured in molarity, which is moles of acetic acid per liter of solution, which in this case is, our solution is vinegar. So what do we have? We have moles, 1.68 times 10 to the minus 3 mole acetic acid divided by, we need a volume of vinegar. In our data table, we recorded 2.00 milliliters of vinegar. The problem is, of course, molarity is measured in moles per liter, and this is a milliliter right now. So again, we would divide by 1,000, which means we move it over 3 places. So we get 0.00200 liter vinegar. And if we do that, this one I need my calculator for. I can't do that in my head. I get sorry, I'm being a little slow here. I get 0.8385 mole AA per liter. Sig figs, 3 sig figs, 3 sig figs. Answer has to be rounded to 3 sig figs. So for me, it would be 0.839 mole of acetic acid per liter. That's my concentration of acetic acid according to my titration. Okay, so let's go and see where we are now. We just finished step 5. So you have, sorry, you have to go ahead and do that for the other 2 trials. So you need your answers for all 3 trials. Then you'll do an average. You'll do a standard deviation. Don't do the standard deviation out by hand. Do it in Excel using the STDEV formula, or do it on your calculator using the stat button, or you can just Google a standard deviation calculator. So do that. Then you need to do a percent error. If you click on these are definitions in your lab manual, so it will bring up the formula for percent error for you. But percent error is just actual minus, whoops, I'm in the wrong place here. Let's go to step 5. Step 5, percent error equals actual minus theoretical over theoretical times 100%. These are absolute value signs, meaning if you have a negative number on the top, you just convert it to positive. So we just want a positive value for percent error. Actual, this is going to be your average of the 3 trials. Theoretical, this is from step 2. And so I'm guessing you're going to have a percent error should be less than 5%, I'm pretty sure. So if you get something that's significantly different from that, just go ahead and check that calculation. And then after you calculate percent error, you want to create a results table. So you need a results table that will have the molarity of acetic acid for each trial. So that is from your answers from step 5. The average, this is step 6. Standard deviation, that's from step 7. Percent error, that's from step 8. You need it in a results table. Results tables always need a title, meaningful title, so it just can't say results. So add a title to your results table. And then that should be it besides the discussion. As far as for the discussion for this lab, some of these questions don't really make sense given the current format. So I want you to do instead, give me a more complete summary of the experiment. So 3 to 5 sentences. Do present the molarity of acetic acid and vinegar and compare your results to the stated molarity. So you're going to compare, like what you got, what it said theoretically, and tell me your percent error. And then instead of answering these other questions, just let me know if you liked having to record your own data, meaning like, did you like having to read the burette on your own in the video with this particular lab, which is a little different than what I did with the last 2 labs. And just let me know if you liked it, why you liked it, and if you didn't like it, why you didn't like it, just to give me that feedback. That would be great. And don't forget, at the beginning of your lab, you should have someplace the experimental goal. So just remember that that has to be there. So I just want to say thank you for putting up with these virtual labs. Tried to come up with the best possible solution that we could think of. This was it, so hopefully it wasn't too painful, and we're really looking forward to seeing you all back on campus next semester. And to those of you who are seniors, I'm really sorry that this is how it's turned out, but it does sound like Merrimack's going to have some type of graduation ceremony for you in the fall, and I hope it's really wonderful, and I hope you're all doing great. And here's my little mascot, Scout. Scout has a little injury, so he's in a cone. But even though he's in a cone and actually has a pretty good injury, you can see he's still a pretty happy dog. So we'll see you next semester.